So we will give you a little bit, the main objectives of today is that we give you an overview of what is VSC, that you know where to find the compute resources that could be very worthwhile for your research. We will not only stick to what we have here at KU Leuven, but we'll look at a really broad picture even within the whole European community. And also, it's not only we telling, we also like to hear very much from you, because I will talk a little bit at the end on how we work, how we obtain our infrastructure, and of course, we always want to get infrastructure that's most useful for the users, for the researchers. So therefore, we really need feedback to do this. First, I guess this is something that we use a slide also for humanities. Let's say, why use central research infrastructure? Well, I guess everybody of you already have at the point from you say, my laptop is not going fast enough, or I leave it running overnight, and then tomorrow I will see my results. But of course, if you need to write your paper on the same laptop, you need a second laptop, you need those things. Probably some of you already have some dedicated hardware, maybe in the lab, but still then you're dependent on funding, and it's a machine that you bought 3 years ago, it's outdated, you would want to have new ones, and yeah, getting the money for it is not always easy. So therefore, the central compute resources are really there for you to use. This is actually one of our tier 2 clusters, Genius, that we have in the data center. The data center is here a bit further along the railroad. So it should be easy for you to use. It gets frequently updated, so it's always state-of-the-art hardware that's in there. Because it's so much, it would be better suited if you have a high peak workload to actually get this done on a system. You don't need to care about any sysadmins. That's done for the researcher. There is not a PhD in the research department that needs to do system updates and things like that. That should all be okay. We do also manage a lot of software things, but you still have the flexibility to do your own stuff. So it really provides a lot of benefits, I think. And there is support from the VSC staff, but the VSC staff is just employees from KU Leuven, just as you are. VSC, what's VSC at Flemish Supercomputer model? I think it's best that we explain a few of the terminologies, because tier 1, tier 2, tier 0, that's something that you hear. Also, it's some kind of a European classification of the size of the system. What is exactly is, the tier 1 of 5 years ago is now a tier 2 regarding to capacity, but the tier 2 is most of the time a system that can be at a university that's within the budget limits of a single institute. While as a tier 1 system, there it's more already goes beyond a single university, it's more like regional, and now in Belgium we have one tier 1 system. And then tier 0, those are really the very large European systems. So at VSC, we have hardware in the tier 2 and the tier 1 layer. Tier 3, that's what's in your office. We don't care about that. We are not managing that. That it's good as you have, but we try to get people from the tier 2 to the tier from the tier 3 to the tier 2. That's part of our job, I think. And then getting them to tier 1, but there is also a way to go to tier 0. So we have actually covering the whole ecosystem. Now, if you look, we are actually, VSC is a collaboration of all the Flemish universities. We get funded by FWO, so by the Flemish government. We have tier 2 clusters at the different sites. Only U Hasselt, because we're funded according to the size of the university. The budget of U Hasselt were a little bit smaller, and U Hasselt decided to collaborate very closely with Leuven. So they just give the money from infrastructure to Leuven, and they are just using the same hardware as us. But apart from that tier 2 layer, we also have responsibilities at the tier 1 level. At this moment, the tier 1 compute is in Ghent. And the previous one was in Leuven. Now the current one is in Ghent. The next one will be in Brussels. But here in Leuven, we also manage a tier 1 data layer, so a very large capacity storage to actually have data together with metadata to keep them on a good way. Not really for archival purposes, but really within the scope of workflows. Then people in Antwerp do support for going to the tier 0 level. They're following up on that. People in Hasselt do more training and outreach things. And then in Brussels, there is also a team for research outreach to industry, because the systems are also possible to be used by external parties, so not only academics. If you're involved in a spin-off of anything like that, VSC can also be used for a spin-off. The only thing is industry needs to pay full cost. The researchers don't need to pay or only a very small portion of the costs. There is a whole management overview on its structure. It's embedded within the FWO. There are people looking from universities and also from the SOCs like VIB and IMEC, or they're also involved. There is also an industrial board, so all that is covered. But of course, most important, tier 1, tier 2, that's the best place to actually start using the systems. And that's a little bit of history, because we already have gone a long way. VSC was first a scientific collaboration. Then in 2009, it really became a project, but very important, in 2013, we got really structural funding, meaning each year we get money both for people supporting the system as for new infrastructure. So our infrastructure is really continuously evolving. At the tier 1 level, it's still more like project financing, but we are now working to acquire a 4th tier 1. So we're still dependent on the next government, whether we will have funding for tier 1 after 26. But normally, if it's in good use, the Flemish government is really in favor of the project, so that should be okay. If you look at our tier 2 system, we already have a number of systems. And actually, more specifically, out of interest for AI, I think we already had some GPU compute capacity already for quite some while. We had the old K40, K80s, but only very few of them. They weren't used that much. With Genius that we bought in 2018, we really had a large capacity for NVIDIA P100s. I think we were the first site within the VSC to have such an installation. They are still active. We try to keep them alive as long as possible because they are out of support. But yeah, those are too scarce of a resource to just turn them off. Now on our new system, we have about 20 A100s, and we are now installing 16 H100s, which are terribly expensive. So, but more importantly, LUMI, the European project where Belgium is involved, can also be very interesting for AI researchers. And very quickly, so we are part of the ISTS team here from KU Leuven. We are organized a little bit with people more facing the users. We and managing the software. This is a support for research. There is the team specifically for HPC, a team for the data management, and then everything to do with infrastructure, with system management. It's within the infrastructure teams, both in the data center team as in the Linux sysadmin team. So we're really working very closely together, but each of the teams have their own expertise. And there is a local steering board overviewing everything we do, that we are on the right track, and also people from KU Hasselt in our local steering board. So that's just a little bit too. So, but if we talk about cluster, what actually is a cluster? So it's a lot of compute nodes interconnected with a very fast network, so that if you have a distributed job that can run on multiple servers at the same time with MPI programming, that you actually can communicate very fast, transfer results from one core to another core. So that's an important part of it, but as the systems were evolving, it's not only CPU nodes anymore. We do have an island with GPU nodes. It's very important. We also already have more nodes with large memory, because some chemistry or bioinformatics really need systems with a lot more memory. And also we have a number of nodes to specifically for interactive work, for development, prototyping, for those things that you actually can get your resources very quickly and don't need to wait too long to start working. But it's not only the compute, there is storage, also a very important part. There is a part that's really safe storage, meaning backed up, mirrored, so you can put your programming there and be sure even if you by accident delete it, there are ways to restore it. But of course, that's more expensive and not really always the best way to real computation on. So therefore, we also have a very large parallel file system. We now have Lustre as the file system. There we have about 4 petabyte of capacity to actually that you can use during your computer. Well, not one user can use 4 petabyte. It's shared by all users, of course. But that's quite some capacity that we have. Regarding software management, we use modules. I come a bit further down on that, but it's centrally installed software, different versions that you can, as a researcher, easy request to start using them. You don't need to bother too much how it's installed. You can use containers, as we see more and more workflows are also launched from containers, which we think can be a good way, especially in very fastly evolving codes. Especially within in bioinformatics, that it's hard to everybody needs to install their own. It's sometimes very tricky. So there containers can also be a very good use case. But also users can install their own applications. You can have Conda to organize your Python codes and things like that. You have storage room for that to do that. So that's also part of the infrastructure. And then important, a cluster is only a real system if you can actually acquire resources and run jobs on these resources. And for that, we use a job scheduler. It's Slurm. It's an open source scheduler. It's used in a lot of HPC centers. So if you learn to work with this one and you end up at other research centers, chances are very high that they will be also using Slurm. So it's good to know that. And then to actually get access to the system, because you can directly log into any of the compute nodes, you need to have some kind of a client. It used to be only an SSH terminal. Now last year we also installed a web interface, open on demand, from which you can get an interface, but can also have a Jupyter notebook, things like that, very easily. You don't need to install anything. You don't need to know too much about the system because it will be asked. So that's all available. So that's a little bit the general overview of what the Tier 2 system is. Now, first, I want to pick on how you can get started, and this is more practical. So every, you can do a few more clicks. Actually, every researcher of KU Leuven, but also master students, if they have a teacher or a promoter vouching for them, or within the context of a course, can request an account. And requesting account is just logging into account.vscentrum.be. If you don't have an account yet, there will be the first page where you need to log in through the central logon ID. And then you can upload your SSH key, but you don't need it at this moment because, for instance, with Open on Demand, you can log in through the central logon ID and you don't need to worry about SSH key and SSH connection. So it's really the easiest way to get started. The account needs to be first, if you request it, needs to be approved by us. So it can take a few hours before it's really active. But researchers will always be approved. For the rest, the account application is also used to, you can create your own groups there if you would want to share data with other users. And these groups will be transferred to Linux groups, so you can, on the system, you can use this as a known groups. You are moderator of the groups. It's also used to account the credit accounting, that the amount of compute time that you have is also managed to groups, so somebody can responsible and add people there or kick people out of it. So it's really very. Also external users, if you have collaborations with other academics, not from KU Leuven, but from some other international site, they can request, we need to do a few things, but they can request an external KU Leuven account, and with that then request a VSC account, so they can log in on the system. You can collaborate on the system as well, so that's all possible. Yeah. And very important, you only need one VSC account to log in to the clusters at the other side, or if you have a tier 1 project to log in to the tier 1, it's all with the same account. So we all arrange that over the different sites. It's available. And with your account, you get a number of storage locations, VSC Home, VSC Data, and VSC Scratch. Home and Data is to store programs and stuff like that. That's a safe space. Scratch is to really do the computing. By default, you get 5 gigabytes, but if you would request 5 terabytes, we will increase the quota. That's not a problem. It's really temporary storage. Scratch, we delete data that's not used there after 4 weeks, so we actively delete data there. If you need more of that storage to share within a research group, everything is noted in the ISTS service catalog. There are ways that you can request it. You need to pay a little bit for it, but yeah, that's just to have it properly managed. The same with compute time. You can request as a starter introductory credits, so just free compute time that you can quickly start using the system. If you are will be using the system more intensely, you need to request project credits. You can do that through the service catalog. You will be charged, or the PI or whoever requests it will be charged, but it's only 5% of the actual cost price that the system is, so it's more like to regulate access, to be sure that the PI is looking that the compute time is used properly, efficiently, because it really has quite some value, what you are getting. For instance, the electricity bill of such a system alone is already quite a nice amount. So it's always good to really think on what you're doing and making the usage as efficiently as possible, and therefore putting a small price on it. It really helps. Yeah. So and this is the interface from Open On Demand. So you just go there with the URL. You will be presented with your, you can click on VSC login, but then you will need to log in with your KU Leuven account and with the MFA, with the multi-factor authentication. So, but you're there, and there are a number of options. You can launch an interactive terminal that's like a login node. You can browse your data, you can see it, but also you can already request a Jupyter notebook. In the backend, it will request, yeah, I have a slide on that next, I think, but you will request some resources and it will start the job on the system, and it will immediately start your notebook within the browser. So actually it's really very easy. Most of you already are used to working with notebooks, things like that, so that's very easy. We also have a code server. If you're doing more coding there, it's also integrated in the browser that you can do there. We will be adding more and more applications here, like even MATLAB or ANSYS, because that's are also frequently used things. So it's good. Next, the login shell still possible, and sometimes if you start doing more and more complicated things, it's good that you know your way around with SSH, what to set up things, and that's still always possible. It's protected. you need to pass the firewall, but it's just to make sure that multi-factor authentication is done. And then you have just your login shell. But here, very important, as I say, the whole cluster is shared by a lot of users. Specifically, the login nodes are there only to do the login, but not to do not any compute, because otherwise, yeah, there are maybe 60 or 100 people using this as a login, and if then somebody starts to use all the resources, then other people are completely blocked. There are limits on what you can do, but you already should know, starting from the concept, login nodes are only to log in and not to do too much other things. And then, therefore, it's first of all, and before using any resource, it's very important that you have a good idea of your own software, your own coding, even if it's on your own laptop, and if you go somewhere else that you actually know, do I need more CPU powers? Do I need more GPUs? Can I use multiple GPUs? I need to transfer so much data. Will that be an issue? How can I organize this most efficiently? Or I need to do 1 million simulations and they're all independent of each other. What will be the best way to do this, submit this on the system? That's always, if you work on your laptop, if you go to tier 2, if you go to tier 1, it's very important to be aware of this. And of course, if you're aware of your workflow, you need to have some idea of the resources that you're using. Now, you don't need to be technical experts for managing systems, but you need to know if you request 1 core with 2 GB of RAM, if you need 4 GB of RAM, if you're requesting the full node, and then you have 72 cores that you're actually using all these cores. So you'll need to be a little bit aware. We have a lot of trainings also to help on that, but yeah, I think it's a good attitude to, from the start, already know this. And then here, this is, for instance, the example. If you need resources in the cluster, if from on demand, it will present you with the options. You need to say which clusters. We have 2 clusters. They're on the drop-down list, so very easy. Which account? Account that's for on which your compute credits are accounted that you need to put. Which partition is the cluster? We'll show that in a moment. So how much hours will your job be running? How much cores do you need? How much memory per core do you request? Stick to the default. Most of the time is the best of advice. Do you need multiple GPUs? Do you multiple nodes? It's all in there. And therefore, to get some idea of the cluster, you don't need to know all the nitty-gritty detail of which version of the CPU it is, but if in your job you need to specify on which partition you're running, which cluster, so you need to know, okay, if I'm running WISE, that's the most recent cluster. The batch partition there has nodes with 72 cores per node. That's something you need to know, because on the older Genius, you only had 36 cores per node, and if you just take your job script from Genius and say, I use a full node, but you're only using 36 cores, well, you're underusing the system. So we always have some batch partition, and it's always tied to a generation of CPU. We have quite some GPUs now, and those are in a GPU partition. They can be, they will be called now GPU and then underscore the version, the V100 or the A100 or the H100 that's coming now. So all that is documented. You can find it in the document. So it's in the beginning, just finding out a little bit and then starting. And then, yeah, all the storage is connected to the system as well. You will be able to use that. And this already a lot of detail, but I did want to show it because this probably is the next step. First, if you request just through the interface, what it in the end, in the backend does, it with Slurm, with S-batch directives, you actually specify what resources you want to get from the cluster. So something we learn in the introduction course or you find in the documentation, but if you're only using the on-demand interface, it's a little bit more hidden. And for starters, it's good, but you see, it's all not that complicated. You only need to use cluster is equals, there's a cluster account equals. You only need to know which directives mean what. And then module load, that's actually saying which software that you will be using. If it's software centrally, we have their module system for it. You can move data around a little bit. It's best to use the environment variables for that, not the full paths, because then you're sure that the value will be always okay. And then you just can start your batch job. It will run for the amount of time until it's completed, or until it reaches the amount of time that you requested. So if your Python program, if you only requested 1 hour and it will take 10 hours to complete, it will get shut down after 1 hour if you only requested 1 hour. So it's better, it's no problem to request 20 hours. If it's done after 10 hours, okay, it will stop and you will be only accounted for those 10 hours. But if you request 3 days and it only takes 1 hour, then the scheduling will be, it will wait longer before it can start, because it needs to look for a window for 3 days to launch something. So it's best to be to take that all a little bit into account. But this is how the script looks like if you're just doing more advanced stuff, or you get to know the cluster more and you submit more and more things in batch. You need to learn this a little bit, but it's not rocket science. Yeah. And about the software, so we try to make this look as easy as possible for you, but in the back end, it's not so easy, because we have quite a lot of, so I think we have about 1,000 software packages, installations, or more, and there are, it's different. Sometimes there are different OS versions in the lifetime of the cluster. For sure, there are different CPU architectures, and for you, you just want to use a version of Python, whether it's on the Skylake or on the Ice Lake. You don't maybe want to bother too much about it. So therefore, we used modules to have also, if you want to use version 3 or version 5 of a software, and every dependency that needs to be there. So if the software is dependent from something else, with a module, just load the module and it's okay. If you want to use another version of the same software, unload this module, load the next one, and it should all be okay for you. So there is some yeah. On the next line, there is some logic to it. How will be? This is already going a lot in detail, but it's just to show you that we take into account, if we compile software for our users, we take into account for which operating system are we installing this, for which CPU architecture installing this. Is this a GPU version or a CPU version? That's sometimes also possible. Then the tool chain version, do we compile it with Intel 2021 or with 2022? All those things are taken into account. There is a very systematic way of doing this, and actually you only need to know how to load these modules. You can compile, install anything you want. Make sure you use then the tool chain that's most appropriate, and that you compile on the nodes where you want to run it, because CPU architecture evolves. If the code is optimized during compilation, it does its optimization for the hardware that it's run. So you can request an interactive node, meaning that you're logged into a compute node and you can actually type in a terminal and then everything gets executed on this node. So you can do this to compile software on the proper place. And if you have problems with it, you can always ask us to help. Yeah, a little bit if for Python R packages, things like Conda that you can manage on your own, that's also supported. Containers, we don't allow Docker containers because there are too many security risks, but we do Singularity or Aptainer, and it's easy to convert a Docker container to one of those. Licensed software, also possible, but you need to make sure that you have the license to run the software, and that if it's with a license server, that it then has enough licenses to, if you're using 10 nodes, that you're actually allowed to, or possible to use it over 10 nodes. So if it's sometimes that you need to have an academic agreement to use this software, for some softwares it's possible, you need to, we can ask you, are you sure, show us that you're allowed to use this software on our system. So that's all there. So that's already, it's, yeah, please.
I know that when you install Python packages using Conda, there's usually some limited amount of compilation still being done to optimize.
Yeah.
Should I have a different Conda environment with different G100s, for instance, and Ys?
Yeah. It's advised to best do that, and I think we have some documentation, best practices to do this. Actually, that you actually, if you're working on Skylake or Cascade Lake, for instance, that not much is different. That will be okay. But if you start using Wise, where we have Ice Lake or Sapphire Rapids, then it's better to have a appropriate install. And then if you launch the job, that with using the proper environment variables, that it automatically selects the right Conda environment. That's on tier 1, for instance, they use Lustre also as a place to install software. It cannot handle all the I/O that Conda typically does. There also on other systems, it's possible that they want you to move Conda environments more or Python environments in a container and run everything from a container. At this moment, we are not pushing users for that because we don't have too much technical problems with Conda. But of course, you need to be aware Conda can be using a lot of disk space, and you will need to manage this a little bit properly yourself too, in order to remain within your quota. But if it's some software that's used by a whole group and that's using a lot of CPU time, and that maybe it's more efficient to install it as a module and in a more optimized way, you can always contact us and we can see if then it's better to just make it available as a module. So that's also possible. But we do believe that the flexibility of using Conda is too much advantageous for the researchers to, in complete control, to always do the updates that you actually want. That we on our cluster, it's not a problem to do this. No. And then indeed, you saw the resources on tier 2 are quite large, but not so large. Especially CPUs, we have a lot more CPU time, but now also GPU time on a tier 1 system. So it's possible to get access on tier 1, but on tier 2, you just need to have the credits and you can submit your workload. On tier 1, you need to submit a project proposal, which will be evaluated technically. So not it just needs to have a reference to the science project that you're working on. And then we all agree that science has been evaluated. We're not looking at that. The allocation board is not looking at that. But it does needs to be technically okay. So you need to do some scaling tests to make sure to prove that you're using the system efficiently. You can request a starting grant to do this on the tier 1 system, and then you can start going. But this is only to make sure, best start on tier 2, know your way around, and then know that you're not limited to the resources that are only on the tier 2. Industrial users are mostly immediately target on the tier 1 system, but there they have to pay the full cost. Where if your project is approved on tier 1, you don't need to pay anything. It's just it's granted. And tier 1, it's not only the compute, there is a cloud environment where you can request, for instance, your own VMs to manage if you need to run some portal or some database or that interacts with your other HPC workload, because the tier 1 cloud needs always to be in support of the HPC workload that you have. You can also request projects there, and also for to have the tier 1 data. Starting grant, you can request anytime, and you get it as fast as possible. It's always granted. The compute grants, there are 3 cutoffs in a year. There is one in February, June, and October, where the evaluation is done, and then you get access for 8 months to actually do this. And on the next slide, this is the whole overview of the system. So tier 1 has about 700 compute nodes, so with 128 cores per node, so are they now at 80,000 compute cores or something like that? So it's really a very capable compute environment. From GPU, there are also all A100s with 40 gig and 80 gig, but in total there are 160 GPUs available there. So it's not small, it's not that big either, but still it's available. And on the next slide, you see that what you can actually ask in a regular grant is for compute time. It goes up till 7 or 10 million core hours, I think. For GPUs, you can request in a grant 1,000 GPU from the minimum 1,000 GPU hours until 40,000 GPU hours. If you need more, you can request and motivate, and we'll see if it's possible to allocate it. For a starting grant, you get 1,000 GPU hours to actually try things out. But so it's not. It's quite some value, but it's not the huge things. And if you need even more, then.
Just wondering, on the starting grant, it says up to 1K hours.
Yeah.
Say I have a project and I request a starting grant, and within that 1K hours, I can do my project. And then 2 years later, I would require 5K hours. Can I then re-request the starting grant?
Yes. No, you can re-request, but actually normally the starting grant would be really to prepare for a full grant. And that's more, so the philosophy is if you can do your work with the starting grant, normally the resources on tier 1 should be, and on tier 2 should be enough to do this work on tier 2. It's a little bit, but, and GPU resources also on tier 1 are more scarce. There start to be more and more requests there. CPU, with the extension we have enough CPU time. There is still room to grow. For GPUs, we are close to the limit what can be used, and that there will be more queuing times. But still, if that's not enough, and then the good case would be look at within Europe. There is HPC, is a European scientific project where Europe is co-financing HPC systems, both smaller scale as really tier 0 systems. Belgium is part of the LUMI consortium that's installed in Finland. It's one of the largest supercomputers in the world. And there actually it's the procedure to get access to this to the Belgian part is not so heavy because Europe is financing about 50% for the rest. So the 50% of the resources will be allocated by a European allocation commission, and there the proposals need to have a scientific review. So the whole procedure is a little bit more heavy. You will need to work harder to get compute time like that. But on the next slide, I put, I think for the Belgian part, it's actually more comparable to what you need to do to get tier 1 access. So if you already requested tier 1 access and it's been approved, you don't need to do that much different to request access on the tier 0 system. And there the difference is that you can get up to, in a regular grant, you can get 500,000 GPU hours. So if you're doing really large modeling trainings and things like that, you really need a lot of GPU hours, then it would be good to have a look at that. But there is one small caveat. The system is completely AMD based, so also the GPUs are AMD GPUs. Everything concerning machine learning, it's getting better and better to what's running on NVIDIA to also run it on the AMDs. I already see some smiling faces. No, but, and we actually really need, and we want to help with it as well. If you were transcribing, or if you want to apply both people from Antwerp as here in local, because we really think that, especially for everything machine learning, that it's good that they also run on GPUs. The GPUs there, the AMD 250 are really comparable with the NVIDIA A100. And in the Limus system, in total, there are almost 12,000 GPUs. So if you really want to run one large simulation, they are available there. So probably it will take a little effort to switch to AMD GPUs, but if you have a large workload, it will really be the easiest way to get access to these resources. From Leuven, Leuven.AI, I think, has that project. There is a testimonial. The link is on one of the next slides. And he did admit, he did say, it took a little bit effort, but of course he could do things that otherwise were not possible to actually be able to do there. So, and it also has a CPU partition, but it's really a GPU-focused system there. So I think, yeah, for the next step. So what I hear, and now can it be a bit more interactive? So our systems are always keeping on evolving, and we will be buying a new tier 1, and the people at VB are doing that. They are doing some information sessions, but also we will be purchasing a new tier 2. We will start information rounds after Easter. On the next slide, yeah, there is. We have on the VSC website that you can find all information, not more about trainings or about procedures. There is also a real documentation website. There is a link in the to the user portal as well. You can find a lot of information concerning trainings. I think the next slide, yeah. We do have quite some from all different levels. That there are some introductory trainings, and that's more to really get acquainted with the system. There are also a number of Linux trainings as well, because we do see that some people enter and never seen Linux also, so there are trainings for that. We have a number of specific Python trainings also that are most of the time very popular. There are also specific programming sessions for Fortran, C++, also for the parallelization of your software. If you're doing with OpenMP or MPI, there are also courses there. Of course, you already need to have some programming skills before starting with a course of that. We are also always looking also for new ideas for sessions that we can work on, or also we can invite external people. We also with the vendors, we have a collaboration that, for instance, when we started with Genius, that some of their people more with AI gave some training specific on our system for special things. If there is a need, or if you think we can help with something, or if you're organizing, for instance, a hackathon yourself, and you would need resources on the cluster, we can also collaborate on that we make a reservation that people working your hackathon can, on the session that needs really be interactive, that can use it. Or also for master trainings, sometimes we can reserve a few notes in the system during the moments of the course, that if you're with students in the classroom and they need to submit something, that it happens immediately. So we try to be as flexible as possible there. And then, yeah, this is the documentation page at docs.vscentrum.be, where you can find out a lot of information of all systems of the VSC, also how to submit jobs, things like that. And then, very important, yeah, we have an email address, hvcinfo@kuleuven.be. It's any questions that you have, just send them to, and we will try to help. Also, if there is interest here to do a real hands-on follow-up session, we can do that as well. I don't know if even if people want it. We can. The next regular intro session is end of February, I think it's in the calendar. But if we have a number of people together, we can always schedule something. So yeah. Also important, if you need to stay up to date, VSC, the LinkedIn page, if you just follow LinkedIn, because sometimes there are courses within VSC, and also there is the National Competence Center, NCC Belgium, who are also helping for LUMI. They also on Twitter or on LinkedIn announcing courses. And sessions can sometimes be around quantum computing, or now AI in the AlphaFold is one of the topics that there is an AlphaFold community already on the cluster, and there will be a session again next week, or even tomorrow, I don't know. So, but it's not bad to follow us on LinkedIn to stay up to date, because there is some activity there. And even if you're not working at the university anymore, but somewhere else, and you want to stay in touch, yeah, it's good.